Hey everyone, are you tired of slow APIs making your application sluggish? You're in the right place. In today's video, we're going to explore 7 optimization techniques that can help your APIs perform at their best. We've all been there. You've built an amazing API, but it's just not as fast as you like it to be. But don't worry, we're here to help. Before we start, it's important to note that optimization should not be the first step in your process. Optimization is powerful, but it can lead to unnecessary complexity if done prematurely. The first step should always be to identify the actual bottlenecks through load testing and profiling requests. Only begin optimization once you've confirmed that an API endpoint has performance issues. With that said, let's get into the tips. First up, caching. This technique is one of the most effective ways to speed up your APIs. By caching, we store the result of an expensive computation so that we can use it again later without needing to redo the computation. If you have an endpoint that is frequently accessed with the same request parameters, you can avoid repeated database hits by caching the response in Redis or Memcached. Most caching libraries make this easy to add with just a few lines of code. Even a brief period of caching can make a significant difference in speed. Next, connection pooling. This optimization technique involves maintaining a pool of open connections rather than opening a new database connection for each API call. Creating a new connection each time involves a lot of handshake protocols and setup, which can slow down your API. This reuse of connection can greatly improve throughput. If you're using a serverless architecture, connection management can be a bit more challenging. This is because each serverless function instance typically opens its own database connection. And because serverless can scale rapidly, this could potentially lead to a large number of open connections that can overwhelm the database. Solutions like AWS RDS Proxy and Azure's SQL Database Serverless are designed to handle this situation and manage connection pooling for you. Closely related to database performance, our third tip is to avoid N+1 query problems. For example, let's say you are building an API endpoint to fetch blog posts and their comments. An N+1 problem will occur if you first made a query to fetch the posts, and then for each post, you made another query to fetch its comments. Now, if you have n posts, this will result in one query for the posts plus n queries for the comments, hence the term N+1 problem. To avoid this, it's more efficient to fetch the data in a single query, or in some cases, 2 queries. One to fetch the posts, and one to fetch all the comments for those posts. This avoids making a separate query for each post comments and can significantly reduce the number of round trips to the database. This improves performance. Moving on to our fourth tip, consider using pagination. If your API response returns a large amount of data, it can slow things down. Instead, break the response into smaller, more manageable pages using limit and offset parameters. This can speed up data transfer and reduce load on the client side. Our fifth technique is about using lightweight JSON serializers. When returning JSON responses from your API, the speed of your serialization process can make a noticeable difference in response times. Consider using a fast serialization library to minimize the time spent converting your data into JSON format. For our sixth technique, we have compression. By enabling compression on large API response payloads, you can reduce the amount of data transfer over the network. The client then decompresses the data. Nowadays, there are even more efficient algorithms like Broccoli that provide better compression ratios. Also, many content delivery networks like Cloudflare can handle compression for you, offloading this task from your server. Finally, we have asynchronous logging. In many applications, the time it takes to write logs is negligible. However, In high-throughput systems, where every millisecond counts, the time taken to write logs can add up. In such cases, asynchronous logging can help. This involves the main application thread quickly placing the log entry into an in-memory buffer, while a separate logging thread writes the logs to the file or sends them to the logging service. Just keep in mind that with asynchronous logging, there's a small chance you might lose some logs if your application crashes before the logs have been written. And there you have it, 7 tips to help make your API faster and more efficient. If you have any other techniques that you found useful, let us know in the comments. If you like our videos, you may like our system design newsletter as well. It covers topics and trends in large-scale system design, trusted by 450,000 readers. Subscribe at blog.bytego.com.